Hi guys, so I'd just like to do question 3 of paper 1 2015. Much like question 2, it's a sequences and series question. In this case it says consider the series Sn is equal to minus 3 plus 5 plus 13. And you can see here that this is quite a simple little arithmetic sequence or series with a common difference. Okay, so you can see the common difference is 8, so between negative 3 and 5, that's 8, 5 and 13 is 8, 13, 21 is 8, so on and so forth. Determine the general term, then I want to write in sigma notation, and then show that Sn is equal to that. Okay, so let's get started. Right, so 3.1. Let's first write down what the thing is. Is determine the. Well, okay, let's actually write down the thing first. Let's say Sn is equal to negative 3 plus 5 plus 13 plus 21 plus all the way to n terms. Right, now obviously this Sn means the sum of, but because they've separated for us nicely, it's just the sequence or the series. Sum of the sequence gives us the series. And this is 3.1. Determine the general term of the series in the form of tk is equal to bk plus c. And that's a little bit weird. So normally what you have is you have tn is equal to a plus n minus 1 times d, right? So that's your standard form of arithmetic. We know it's arithmetic, as I mentioned. That's your standard form, and they're giving us this weird looking form over there, but that's quite simple because all we need to do is expand this. So we have a plus d times n, so it's dn minus d, and if we simplify that a little bit more, we see that this dn is simply dn plus, and then we have a minus d. And if we look at that and we compare that to this one, which is bk plus c, this part here is c and this part here is obviously our bk, where k is the same as our n because they've written it here as tk. So that's effectively our n, just like we have tn here, and then that's our n over there. Okay, so if we want to work it out, we say, well, I suppose we can use tk if you want. Tk is equal to a. What is a? Well, a is the first term, negative 3 plus n minus 1, oh sorry, n k minus 1, because we used tk instead of tn, k minus 1 times d, and the difference is 8, as we mentioned, minus 3, so 5 minus 3 equals 8, or 13 minus 5 equals 8, so the common difference is 8, so we have 8. We work that out and we see it's negative 3 plus 8k minus 8, minus 3 minus 8 is minus 11, so we end up with 8k minus 11, and that's your answer. So we've written it in that form. We've got it in the form of bk plus c, where b is 8 and then c is, in this case, minus 11. Right. Question number 2. Question number 2 said that we must write it in sigma notation. So 3.2 is sigma notation, and just to recap what sigma notation is, we have n equals 1 because we're starting at the first term. If we were starting at the 10th term, n would equal 10 all the way to some n value, and then you put simply your tn formula there. So you're summing each term. So in other words, this is the same as saying t1 plus t2 plus t3 plus all the way to tn, and that equals the sum of your first n terms. Now in this case it's a little bit different. So we say Sn is equal to the sum And instead of saying n equals 1, we say k equals 1, because their n term and their k term are the same. So we have the same n and k term, and they say it goes all the way to n. So we should actually write this as sk. And what is our tn? Well, we saw the previous thing because we calculated it was 8k minus 11. Right, and that's about it. Now, just to note, you'll see on the memo, so that's your answer, by the way. So if you look on the memo, you'll notice that it also says sk is equal to, and they have the sum of k equals 0 to n minus 1 of 8k minus 11. Now, I don't particularly like doing it like this. I prefer this method, but it's the same thing. Whereas this one, they're saying it goes from, no, sorry, it's not 100% correct. Plus 1 minus 11. So what you're actually doing here is you're saying, well, start at term 0. You're going to term n minus 1. Obviously, if you start one term early, you have to end one term early, and then you have to plus 1. So when you substitute everything in, it's going to give you the same answer. But that's weird because you're starting at 0, whereas starting at 1 makes sense because you're starting at the first term. So I don't particularly like this method, and I would stick to that one. Right. Question number 3. It says, show that, 3.3, show that Sn is equal to 4n squared minus 7n. Well, what's the sum formula? Sn, we don't actually have to use the sigma notation anymore. Sum formula for an arithmetic sequence is n over 2, 2a plus n minus 1 times d. So we look at that and we say, okay, well, that's just n over 2. 2 times our a value. Our a value is minus 3. Plus n minus 1 times the difference, which was 8. Now we can multiply all that out and simplify it. I'm going to multiply this n over 2n, and that n over 2 times negative 3 is just the 2's cancel, so we're left with negative 3 times n plus n minus 1, and then 8, we multiply these two together. 8 times n over 2 just becomes 4n, so we literally have 4n on the outside. Okay, we can multiply all that in, and we get negative 3n. And then this 4n times n is plus 4n squared, and then 4n times minus 1 is minus 4n, and you can see this simplifies to 4n squared minus 7n, exactly as they wanted. The next question here says, another sequence is defined as q1 equals 6, q2 equals that, q3 equals that, q4 equals that, q5 equals that. Now hopefully you notice that all that they've done is they've changed the first term. So they've said minus 6 is the first term, then minus 3. So here we had minus 3, 5, 13, 21. Now they have minus 3, 5, 13, 21. But they've added this minus 6 as our first term. So that's the only difference they've done. So effectively, it's the same thing as what it was before. The only difference is they've added one extra term at the beginning. Okay, so they're asking the first thing. It says, write down the numerical expression for Q6. Alright, the numerical expression for Q6. But we know what the original thing was. It's plus 8. So if we have negative 6, negative 3, plus 5, plus 13, plus 21, where this is Q1, Q2, Q3, Q4, Q5, and obviously Q6, we just plus 8. Now you could also use the original formula that we calculated, Tn or Tk in that case. Let me just write Tk is equal to, and we found it was 8k minus 11. If we do use this formula, we'll just have to say T5 because obviously we were 1 unit back. But you plus 8 that, you get 29. So obviously the answer is 29. So 3.4.1 is equal to 29. Okay, 3.4.2, it says calculate the value of Q 129. So they want the 129th term. That's Q1, Q2, all the way to 129. So it's literally this. We can use the same as the previous thing, which is pretty great. Or we can calculate a new thing. So it's actually really simple in the sense that Q129 is equal to, remember I said we mustn't forget this, that we already calculated, and we've already calculated Sn for that. Right, that was given in the previous question. That was given over here. So we know that Sn is equal to 4n squared minus 7n. And we know that this is exactly the same thing, but with one extra term at the front. So 129 terms of Q is going to equal 128 terms of Sn. So that's equal to S 128 minus 6, because we have to add this minus 6 which is in the front. And that really is that simple, because we can say, well, S 128, oh, let's just write it a little bit differently. S 128 is equal to 4 times 128 squared minus 7 times 128. Okay, so I'm going to write it over here. We have 4 times 128 squared minus 7 times 128 minus 6. And 4 times 128 squared minus 7 times 128 minus 6. You put that into your calculator and you're going to get 6, 4, 6, 3, 4. And that is that. That's all there is to it. You could go and calculate a completely new formula. If you didn't notice this guy over here, if you didn't notice this, you could calculate a completely new formula where you say, okay, well, the difference between there and there, difference between there and there, you'll get literally the same thing. You'll get this. So it's just extra work, but in terms of difficulty, not difficult at all. And that is question number 3 done.